Hi guys, welcome to my YouTube channel Rubixx Structures, where we teach you how to design structural elements. On today's tutorials, we are going to be taking you on a journey on a tutorial on how to design these structures, a ProtaStructure design for beginners. Okay, this tutorial is going to have a step-by-step guide on how you can design these structures from start to finish, designing the columns, designing the beams, designing the slabs, and also designing the footings, the pad footings. Do well to subscribe to our YouTube channel if you're just joining us for the first time. Like the video, and do well also to subscribe to our YouTube channel while we start this journey together. Welcome. Okay, so in order to start the tutorials, the first thing you're going to do is we're going to come to an external reference drawing. So we're going to pick a DXF file that we already arranged. I already arranged it, and in the description of this video I'm going to be dropping the tutorials on how we created this particular DXF file that we are using for this design process for these tutorials. You can just check in case you find it difficult trying to extract architectural drawings to drawings you can be able to export, so you can use them on ProtaStructure. I'm going to drop the link in the description so you can check it out and you can learn from it. Okay, so I've already prepared a DXF file that we are going to be using here. Okay, and it's already here, so I can click active here. I've added it. So you've seen the DXF. If you do it active, you see it's showing below here. Okay, the next we are going to do is we are going to, you can decide, let's not use colors. Next we are going to do is to import. We already created grids and columns, so we are going to be importing both the grids and the columns. All right, and we're going to click on import. Okay, so it's converting floor plan. Number of lines that is converted to grids, it's 12. Number of polylines will be converted to columns, 24. So you can just close this. Okay, if you zoom in, you're going to see, so you can click OK, and you zoom into the plan. Zoom into it, you realize that you have your columns at 230 by 230, 230 by 230. Okay, 230 by 230 columns, all of it. So we already created the columns. Same with the grid lines, we already created them. So next we are going to be doing is we are going to be changing the labels for this grid. So we can just highlight the horizontal, all of it, right click, and you come to properties. All right, so our horizontal grids, we are going to be listing it in alphabetical order. So the A1 is going to be A, the A2 is going to be B, A3 C, A4 is D, A5 is going to be E. Okay, once we are done with that, you can close that, and you okay, I think we didn't change A5, we just changed again. Come to properties for the grids. So the label here, we just change it to E. You press update. Okay, it's going to change it, you close it, you can escape that. Okay, things we are going to change is also the grid for this one, so we can just highlight it, this 4 first of all. It's going to be numerical. The vertical is going to be numerical, so same thing, properties. A6 is going to be 1, A7 is going to be 2, A8 is going to be 3, A9 is going to be 4. You can click enter, so it's changed, so you can close this. So you have 1 2 3 4. Then you have 12. 12 is going to be 5, 11 is going to be 6, and 10 is going to be 7. So you can just highlight that and click on properties. 12 is going to be 5, don't forget. 11 is going to be 6, and 10 is going to be 7. Okay, press enter, so you can close that. So you can have, for the vertical, we have 1 2 3 4 5 6 and 7. Okay, after that, just so you're sure, you can press your escape key, then you right click on any place on your environment, come to members table, come to column table. Okay, so you can make sure that all the dimensions of your column is 230 by 230 and the eccentricities are 0. Okay, just to confirm that, it's just to check, so you can confirm it. Okay, you can also come to your review, and you have, let's fix, in case we made a mistake in our axis. Maybe we drew axes that were not linear or they were not orthogonal, so you can fix almost orthogonal axis. Okay, so for the DXL file we created, there are no nearly axis, is not affected, so that means all our axes are straight lines. So you can click OK. This is just the preliminary, so you don't end up making mistakes. Okay, so we have our columns. Okay, so next we are going to be doing is we're going to be adding beams to this column. So we can come to our architectural plan, come to your AutoCAD architectural plan. Okay, so we can find so we can know how we're going to arrange. So I made, okay, so this is what I made. This is how our beam layout is going to look like. We're going to have beams around here. This other area here is the staircase. Okay, so this is how the arrangement of our beams will be like. Okay, so we can just come back to our ProtaStructure, click on beams, give it time to bring the drop down menu. So our breadth of our beam is going to be 230. We're going to be using is a residential beam, so we're going to be using a 450 depth of beam. Okay, eccentricity is 0. Okay, no changes in these, so we can just add. Click on the first point you want your beam, so you can drag it to the last point. Okay, so you have your beam. Sorry, you can just click on beams again. So that's 230 by 450. All right, so that's simple. Click here, you drag it to the end, so you have our beams like this. Okay, you can press escape. Okay, next part we're going to be fixing our beams is horizontally from the first here to the other end. Click escape again, from the first to the last. Okay, so this is our garage area. This is how it's going to look like. Okay, so this is it. Okay, we can also have, from our plan properties, we have a beam here, so we can just add the beam here. This is the staircase I told you about, so there's no beam here at this staircase, so you can click on this one and delete it. Okay, if we come back to our architectural plan, you notice that this is the living area. Okay, so we are not going to be having a beam across here because we don't want a drop down beam showing here, so we're not going to have a beam across here. Okay, so we can just come back to our ProtaStructure file and we're going to delete this beam. But you know, the first, as I said earlier, the ground floor, you have the garage area at the left side, and we have the living area. You have a 2-bedroom apartment, you have the kitchen, and you have the toilet area here. So this is how the ground floor is going to look like. Okay, you can come to your view, right click, and come to your 3D physical model. Okay, so this is what we have for the 3D physical model. Okay, after adding our columns and our beams. Okay, that's it. So next we are going to be adding slabs. So we are going to come to slab. Okay, it's asking us to define load cases, so we can define that before we add slabs. So okay, we're going to come to loading generator. Okay, we are going to just define the load patterns. This is the load pattern. We're going to be loading it alternately. Okay, we are going to be loading them alternately. Okay, so this is what we're going to use. So we can just use OK and allow it to generate for you. So it has generated 11 load cases for you, right? With the dead load and the live load, okay, with different combinations. You can click OK. Alright, so we have a drop down menu for a slab. We are going to be using a 150 depth of slab. Concrete cover is 25. We're going to be using type 1 for now. type 1. So we can come after general. The next thing we're going to come is we're going to come to loads. Okay, so after this we have self weight of 3.6. This self weight, how it's calculated is, you know, from your general you have a depth of slab of 150, so 0.15, you change it to meter, 0.15 times 24 is going to give you this. Okay, that's how they had the self weight automatically changes the self weight. So if we change, let's say we change this height to 200. Okay, we come to loads, you see it has changed to 4.8. okay, so we're going to be using a 150 depth of, okay, come to loads. So what's dead load are we going to use? You can just click down, it's a room, so we're going to be using a room. So dead load is 2.38 automatically from the software. So for impose load, you can input an impose load, but we're going to be, you just right click on the impose load here, right click on it. It's going to give you a list of the minimum value of impose load you could use according to Eurocode 2, because we're using Eurocode 2 in this design. Okay, so it's just a general domestic use area. Okay, so we can just a general domestic use area, so you can just click 1.5 there, and that is it. So we come back to general. We are going to be our insertion is going to be beam region. Okay, so you're going to hover around the beam region and click there and give it time while it loads the slab. Okay, so that is it. So we can just be clicking on the areas you want your slabs. Okay, click on this area, you click here, click on this area, click on this area, and click on this area. Okay, so you can just check what we've done in the 3D modeler, what we've done. Come to your 3D view, so you check it, and this is what we have been doing. It's also important that as you are designing and as you're imputing this, you're also checking the architectural drawing to make sure that whatever or wherever you place your column is corresponding to what the architect proposes, so you don't end up placing columns where you're not meant to place columns, or placing beams where you're not meant to place beams, and also to know where to place slabs and where you have cantilevers and all of that. Okay, we can come back to our plan. Next we are going to do is we're going to check our architectural drawings to confirm what you've done. So you can come to your architectural drawing. Okay, so this is it, our architectural drawing. This is what we have done. This is the garage area, the area where we have a beam layout like that, and the staircase, the veranda, we have our kitchen and all of that. So next we are going to do is we are going to check this. Is a cantilever, yes. We are going to check the value of this cantilever, the dimensions of this cantilever. Okay, so we can come here because it's a cantilever slab, so we are going to just come here and check it. 0.715, so we can match properties, so you can know the dimension. Okay, so from the dimension here is 715 millimeters. Okay, there's a cantilever slab ahead of it. If you check the end elevations, you're going to see that this is the ground floor we are doing it. So there's a cantilever slab to the left for the upper room. Okay, so this is the cantilever area here. So we're going to come to our ProtaStructure. We're going to come to slab. We can come to, we're going to change this type. We're going to change it to a type 12. Type 12 is cantilever. Okay, so I come to load, come to general, change the height to 150 as usual. Come to the loads, enter value for it. So it's going to be a room. It's a room, it's not a balcony. So general domestic is a room, is not a balcony. So you can come to cantilever. The cantilever length, you're going to put 750. No, is it? Sorry, we're going to check that again to make sure we confirm the dimensions for that. So let's confirm the dimensions for that cantilever. So it's 715. Alright, so we come back to ProtaStructure. 715 millimeters. Okay, so we can just click the first point, click to the second point, then move the cursor left. So you're going to see the line there drawn there. So you click any point and that slab has been added. Do the same thing here again. Click the first point, click the second point, move your cursor outside, and it's been added. Same thing here, you click the first point, click the second point, and you move it outside, and your slab has been added. Click the first point, click the second point outside and your slab has been added. You can press escape. So this is what we have. You can check your 3D again, 3D view. Okay, so this is it. You cantilever slab for that area. Alright, so come back to your story 1 plan. Come back to your story 1 plan. You can check your architectural drawing again to be sure. So that's what we have cantilevers. We have it here, 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 and here. So those are the only cantilevers we have. Okay, those are the only cantilever areas we have. Going to come back to ProtaStructure, and the next thing after slab is we are going to load our beams. Okay, so we can just click on a beam, right click on it, so you can just click on the beam, right click on it, and you're going to come to edit loads. Click on edit load, and allow the load window to load. Okay, so you're going to be having a wall load, not a point load, not a uniform load. You're going to be having a wall load, so you click on wall load. Okay, so it's a user defined wall. This is the label. You can edit the openings for your wall if you want to edit openings. Okay, so software has already given me that the unit weight of the wall is 2.40, but you're not going to be using a 2.40 unit weight because we are going to make an inclusion of plastering. Okay, unit weight of a block, a 9 inches block, is 2.40. Right, but then we are going to be adding load too for plastering, because once you plaster your walls, it has also added more load. So we can change it. Let's just use 3.40. Okay, so what is the height of our wall? The height of our wall is usually calculated by going to what's the total story height minus the drop down of your beam. You're using a 150 slab and a 450 depth beam. So 450 minus 150 is 300. Okay, so you have a 300. So what's the height? The height of our story is 3000. Okay, height of our story is going to be 3000. So 3000 minus 300 is about 2700. So we are going to be using height here of 2700. Okay, what's the thickness of our wall? Thickness of our wall is going to be a 230 wall. Okay, so automatically it calculates the average load. So the average load here is at 9.180 kilonewtons per meters. Okay, so you can just click on this and it has been added. The load has been added, 9.18 wall load has been added. So you can click OK, and that load has been added to that wall. So if you escape that, you see that the color changes to brown. That shows that wall has been added. If you come to your 3D view and rotate it, you're going to see that load. That's our wall load there that has been added. Okay, that's our wall load has been added. Okay, next thing that we're going to do is we're going to be adding that same wall load, because around it we have walls. Wherever it is, there are walls there. So we're going to be adding that same wall load around our buildings. Okay, everywhere around our building. Okay, so we're going to come back to our plan view. Click on that. We want to copy load. So it's dead load, wall load. You're copying, and it's okay. Copied wall load. So you're going to come here to our structure tree. You click beam 1, then you hold your shift and click on the last one to select all the beams. Okay, you've seen all the beams have been selected. So you can press Ctrl V. Okay, once you press Ctrl V and you escape all the loads, okay, come to 3D and all the walls have been loaded. Alright, all the walls have been loaded. Okay, and this is how it looks like. But we don't need on top, we're not going to be loading this particular member, right? We're not going to load this particular, so we can click on this, right click on it, and we're going to delete loads here, so you just dead load wall load here and okay, we won't be loading this side of the wall. And also, since there's a cantilever around here, this is a room, this particular wall also will not be loaded. You can click this, right click it, delete the load here, this here, okay. You can just select multiple, click the first beam here, click another beam here, click another beam here, right click, delete loads. So we're going to be the 3 dead load, wall loads, deleting the wall load, so you can click OK. And the wall loads, they have been deleted. Why? If you come to architectural drawings, okay, you notice that on this wall here, on the first floor, this is where that wall is, and there's no wall here. That's why we are removing the wall load there, so you don't overload your structure, right? So this is the area where that wall is on the first floor. There's no wall here, there's a cantilever, so the wall comes here. So we're going to move that particular wall load there. All right, that's how it is. That's how you load your structures. So you come back to ProtaStructure, okay, that's you come back to your 3D view, and this is how your structure has been loaded. Okay, come back to plan view. So this building, go to architectural view again. This building has a ground floor, first floor, second floor, and a roof plan. So we are going to have a 3-story building. So sorry, ProtaStructure. I'm going to come to story, right click, and we're going to impute and insert story. This is a 3-story building, so we're going to impute 3-story building. Story height is 3000, I told you earlier, so we click OK. Yes. Okay, so we have the first, we have the second, and the third. Okay, I'll go back to the first. Since this building is a symmetrical building, whatever is on the ground floor is the same thing to the last floor. Okay, so we are going to be generating this story upwards. All right, so we're going to come to story, right click on it, generate story. So we are going to be generating from story 1 to story 2. We're going to generate columns, shell walls, we're going to generate everything, members, we are going to generate everything. Okay, so we click OK, and whatever we have on the first floor, process complete, so you can close this. So you notice that whatever we have on the first floor is the same that we have on the second floor. Okay, so as I've always said, you're going to confirm this on our architectural drawings, but make sure we confirm it as you're designing. So on the first floor, you notice that it's no more a garage there, it's now a living and dining area, just like this other side is a living, sitting and dining area. Okay, so we're going to delete this. On the second floor, we're going to delete this beam, delete this slab, and also delete this slab. We're going to make that slab a whole slab. So properties, using the same properties there, we're going to have a beam here, a slab here. Okay, then come to your 3D view to look at what you've done. So that is it. Okay, come back to our plan, story 2 plan. I'm going to generate this to the 3rd floor too. So story, right click, generate story. We're generating from story 2 now to the 3rd story. So from story 2 to the 3rd story. Okay, so okay. Right, so we are now come back to our 3D view. So this is what you're going to see. So we're going to see on your, okay, but then we are going to be making changes to the top floor. We're going to be making changes to our top floor because we are going to have a roof there. So come to plan. First thing we are going to do is we are going to be deleting all the beam loads. We're going to, since the roof, that's the top floor, that's the roof, so we don't need walls on the roof. All right, I'm going to select the first one as always, hold your shift, the last one, and you can right click on that. I'm going to delete loads, dead load, wall load. You're deleting all the wall load, so you click OK, and all the wall loads have been deleted. You can press escape. Alright, besides that, we're also going to be deleting this cantilever. Okay, we are going to be deleting all the slabs. So this is a roof that are going to be there. We're going to be deleting all the slabs on the top floor. Okay, deleting all the slabs on the top floor. Okay, I'm deleting all of it, so that's what we have. Okay, you can come to a 3D view to see it. So that's it, that's what we have. The ground floor, the first floor, and the second floor, and this is going to be where your roof is going to be. So these are just the roof beams. Okay, come back to our plan. Okay, because of how the roof is going to be like, personally what I'm going to do is I want to add another axis here. So I click on my axis 1, right click on it, and I'm going to offset this axis. I'm offsetting it to the left side. So I'm going to be offsetting it to about, okay, I'm going to be offsetting it to 600. I'm going to offset it to 600. Okay, so F2 minus 600. Press enter. So I've done that offset. Same thing here. Right click, offset axis. F2 600. Okay. I want to delete this. To delete this also, delete this also, and delete this. Okay, I'm going to also delete this beam here, delete this beam, delete this beam, and delete this beam. Okay, so now you can click on this one, right click, into properties. I'm going to have a beam here. So this arrow shows that this is a cantilever beam. Okay, same thing, you're going to offset it here too, to offset here too, offset that too. Yes, splits. So that's how the top is going to look like, right, like this. So you can use the same, right click here, properties, use the same properties. Okay, so from here now to the drag it to the top. Yes, you can split the beams there, right? So this is what we have for our roof plan. So we come to story 1 to look at it. So this is what we have for our roof plan. This is how it looks. This is how our building looks like. Okay, so these are plan view for story 3. Plan view for story 3. So because of the load of the timber and the aluminum sheet and all of that, we are going to load these beams, but then we are not going to be loading it as much as we would load a wall. Okay, so you just click on the beam, right click, still edit loads. Alright, so it's going to be a wall load. Alright, so we have a unit weight of wall is to 3.40, or we can change this not to 3.40, we can keep it as 2.4. Right, so what height are we going to use? We're going to just use a 1 meter height. Okay, depending on the picture, I'm going to use a 1 meter height. Okay, click on the beam. Okay, so we have a 2.4, 0.024 kilometer per, right? Okay, sorry, this is going to change that. Sorry, this is 1000. Sorry, so we update it. Okay, so we have a 2.4, it's 1000. Sorry, not 1 millimeter, it's 1000. That's like 1 meter. Click OK. we have loaded it. So as usual, you click on the beam, right click on it, copy this, copy the wall load. Okay, go to your story 3, click on the first beam, hold your shift, click on the last one, select all your beams. Sorry, hold shift, click on it just to select all the beams. So you can Ctrl V to paste. Okay, so this is what we have. So we have now. We are done modeling. So to check what we have modeled, we can just come to review, come to building model check. Okay, and start. Just to make sure that whatever we model is correct. Just a preliminary stage. Okay, so building model check complete. Number of errors is 0, so our model is correct. So if you have followed us up until this point, I want to tell you congratulations. I mean, we are going somewhere, you're learning. Okay, so we are done with modeling. Next thing we are going to do after modeling is we are going to analyze our structures. We want to analyze our structure. So we are on story 3. Make sure you're on story 3. So you come to analysis. Okay, and we're going to come to the load decomposition. We want to decompose the loads from the slab to the beams, which will send it from the beams to the columns. Alright, it's very important to do a load decomposition, or you do a finite element flow analysis, so it can distribute the loads evenly. If you don't do this, the loads will not be distributed, and whatever building analysis you've done might not be correct. Okay, so we're going to come to the load decomposition by finite element, or you can use the finite element flow analysis depending on your choice, but I like using the load decomposition by finite element. Okay, once you click on that, allow you to save your project first. Okay, notice that I said earlier we are on story 3, the top story, so you can select all of this. All right, and now once you select all of it, you just calculate slab loads. Okay, so it's saying that there's no slab plate exists in the story. So on the third story, we are going to have a roof, there are no slabs. Okay, so you just tell it okay, and so we're going to leave that particular story and go to the next story. So you see generating model geometry starting from story 2. Okay, so an article model is being prepared for the story 2. So give it time while it loads and it analyzes and decomposes your load in finite elements. Okay, so that has been done. You can just click OK. Okay. So analysis is being complete for the story 1. So you notice if you come here to check, you see that story 3 has not been done because there are no plates, there are no slabs on the story 3. So for story 2, it has decomposed the load from the slabs. From story 1, it has decomposed also the load from the slab. Okay, you can also, if you want to display the analytical mode, they can display. Okay, but that's complete. You can just close this. Okay, and the loads has been decomposed, it has still correct. Okay, so next thing we are going to do is to come to our building analysis. click on building analysis. Okay, so this is the pre-analysis phase. Pre-analysis, right? You can come to your setting center first of all, just so you can check your settings. Okay, this is the code you are using. Okay, leave that first, you can just check that later. So you come to edit materials. You have to edit your materials, what concrete grade you're using, what use stress of your steel are using. So for our columns, you're going to be using, for the design, you're going to be using a grade 2025. So you're going to use 2025. You come here, apply to all members. Okay, and click OK. Okay, for the steel use stress of your steel, you are going to be using a 410. Alright, 410, so you can apply to all the members. You can cut for this rebar diameter, you can edit a rebar diameter. Please, I'm using a Prota 2022. If you're using 2021 or 2018 or 2019, this interface will be different. Okay, so but then it's still the same thing. If you hover around here, you realize that this is your column. What reinforcement do you want to use for your column? For columns, you're going to be using Y16. So you untick every other and just every other rebar size and just leave Y16. Okay. Second one is wall. We don't have any wall in this diagram, so you can in this building, so we can just leave it. So beams. Okay, for this wall means shear wall, not literally a wall like a block wall. This means shear wall. Okay, but we don't have any shear wall, so we just leave that. This is a beam. So what reinforcement are we using for our beam? We're going to be using a Y16 for our beam. Okay, using a Y16 for our beam. This next one is slab. What reinforcement are we going to be using for slab? We're going to be using a Y12 for our slabs. Okay. Next one is rib slab. We don't have any rib slab. Next one is foundation, footing. What? We're going to be using a Y12 for our footing, so we just stick Y12. We can just use Y12 or Y16. Alright. Next thing here is your links. Okay, so what are we using for our links? We're going to be using Y10 for our links. So you just untick every other one and leave Y10. So that's it. The next one is horizontal web bar, vertical web bar. Okay, so you can just leave that and you can click OK. OK to apply. And you notice a concrete grade is 2025 and this is grade 410. You can click OK. We have done with editing of materials. The next thing you're going to come is you're going to come to analysis. We can check our model again. You can do a building, but we've already checked that. So next we are going to do just to click on building analysis to analyze our structure. So you click on building analysis. We're going to be designing column. We're going to be designing beams. We're going to be selecting all bars if what we have provided doesn't pass. Okay, so you just build analysis. And you give it a little bit time for it to analyze the structures. Okay, so building analysis is completed successfully. Okay, so a directional relative storage drift satisfies the limits. Okay, that means what we did, our model and everything is done properly. You can click OK. Another very important thing after analyzing your structure is for you to check the load comparison report. The axial load comparison report is very, very important, so you can click that to check. Okay, so on the load axial load comparison report, you're going to see total loads based on slab loads. You look at the total loads. All right, you're also going to check the total loads decomposed to beams. As I told you earlier, these things decomposes these things. Slab loads decomposes to the beams, while the beams decomposes to the slab when you were doing your load decomposition. So for the first one, the total loads just based on the slab load without decomposition, you realize that the total is 5,667.2 for the dead load, and for a live load it's 5,600. No, it's not 5,000, it's 561.2. Okay, so what usually happens is that you are going to compare the dead load based on slab load, and you're going to compare the total loads to dead load based on the one decomposed to the beams. You notice here for the load is 5,667.2 for dead load based on slab loads, and for a total load it's here 5,651.6 based on the one that is decomposed to beams. You have to check this. Why? Because the discrepancies between the two like this should not be more than 5%. If it's more than 5%, that means it exceeds the limit that the code allows. It exceeds the 5% the code allows. So you have to make sure you go back to your building model, your building, and change it and analyze again to make sure that this is within limit. Usually sometimes it can be the same, but whatever variations there are, it shouldn't be more than 5%. All right, it shouldn't be more than 5%. Okay, so you just compare it and make sure that it's not more than 5%. Same from the dead load, do the same thing with the live load. See, the live load is 561.2 here, while here it's 557.3. It's within the 5% discrepancy that the code allows. Okay, we can end this. Come to our post analysis. Let's check our column and wall design. So you click on your column and wall design. Okay, so you see all you can expand this and you see that all our columns passed. Okay, it's providing 4x16 for the columns and links y10 at 225. Right, so you can click on one, do interactive designs just to see a section of what the column looks like. Okay, so this is a section of what it looks like. Okay, so you have a 230 by 230 columns, and this is you have 4x16. Okay, you can check the moment diagram. Okay, so this is the moment diagram. You have the shear force and the moment diagrams. All right, for that column, you can just end that. Okay, so this you can click OK, and that's that for the column reinforcement. You can end this. So we're going to check our beam reinforcement design. Click on our beam reinforcement design. So we check. Okay, you can scroll down. You can expand this. We check all our beams have passed. So we can check one of it. Let's just click one, and we click on the interactive design to see what's happening. Okay, so what it has provided 2x16 top and bottom, even at the support 2x16, and it has provided links y10 at 275 spacing for the links. Okay, that is what it has provided. You can come here to your diagrams to look, to check your moment. This is your shear force diagram, and this is your moment diagram. Okay, this is your shear force and moment diagram for this particular beam. Depending, this is the envelope diagram. This is the envelope diagram for it. So you can check the moment and shear force depending on each load case, just the dead load, the live load, the factored live load, and all. So but then you can use the envelope just to combine all of it. Okay, that is it. And we can end this and click OK. And then this, so that's for our beams and our columns. So we can check our 3D view. Check our 3D view, come to your review, your visual interrogation, and check your design status. Okay, so you need everything now is green, means that it is okay. Everything is in green, means that drawing and it's okay, very very okay. All right, okay. Next thing we are going to be doing, you come to our plan. Next we are going to be doing is we are going to have to design. We have designed our columns, we have designed the beams. Next we are going to do is to design the slab. So we come to story 1 on our plan, story 1, click on story 1. Okay, you come to modeling and you check your slab strip. You want to include slab strips. Okay, so the direction is the x is horizontal, so you are taking the x direction first. What type? You're going to use analytical strip because we have already analyzed our unit. So we are going to use analytical strips. It's going to use whatever we analyze after I load the composition to provide reinforcement when we add the strip. Okay, so now the boundary conditions. The first boundary condition we have here is that this is a cantilever. Okay, so at start you're going to pick this side. This is a cantilever. Okay, pick the third options at the start. The third one is a cantilever. Okay, and the last one is also a cantilever. Right, so we can just click outside, hold your control key for a straight line, and you click. All right, you give it time for it to add the strips and also add reinforcements. Okay, so that's it as provided. If you zoom into it, you will notice that I provided Y12 at 250. Okay, so you're going to do the same thing here. Okay, for this side it's going to be from a beam. Boundary condition is beam to beam, so we're going to click from here, hold your control key. Okay, leave it, make sure it's a straight line control, then you end it. Okay, it has provided. This other one, it starts from a cantilever and it ends here. We cannot cross because there's a space here for a staircase, so it's going to be from a cantilever to the beam. So it's going to be from cantilever. Okay, hold your control key to make it straight. Right, this other one is going to be from a beam to a cantilever. Click, sorry, escape, you click a point, hold your control key to get the straight line. Okay, so that is that. Okay, that's for the x direction. Okay, so for our y direction, same thing we do, change it to your y direction. Same thing you're going to do, the boundary conditions. We're going to start from a beam to a beam. So this is the boundary condition, beam to beam. So you just click, hold your control key for a straight line, and you apply. Hold your control key for, you apply. Hold your control key for a straight line. Okay, hold your control key for a straight line. Hold your control key for a straight line. Okay, for this you can also add here, it's going to be cantilever to cantilever. Okay, so hold your control key. Usually it's not going to add because there's no, so it will just, you can leave that area like that. Okay, so that is how you add slab strip. So if you zoom into it, you're going to realize that's provided reinforcement. So it's providing Y12 at 250 spc for our slab. Okay, meaning that all our slabs has passed. So you can also check that by coming to your design, coming to, you have design columns, you have design story beams. Okay, next is come as slab analysis and design. So you click on slab analysis and design just to confirm. Okay, so this is, it means that it has passed. The design status ticks it that it has passed. Or you can still do slab strip design and delete and reselect all bars. Okay, you can just delete that and reselect all bars to check it again. Okay, it has finished, so you close, so it has passed. And you see it has provided Y12 at 250, Y12 at 250 for all for the ground floor. Okay, so you can click OK. You can do well to repeat that for story 2. Okay, we can repeat that for story 2 and repeat that for story 3. So let's do it together and impute slab strips. All right, so direction X. Okay, then for direction Y, okay, for direction Y, it's going to be from hold your control key to make it straight. Okay, so that's it provided. You can do same for story 3. Okay, there's no slab on story 3, so you can just come to design, slab analysis and design. Okay, so we can just check that again. So slab strips, delete and select all bars for all the stories, so we delete design that. And okay, so that's that. We have designed our slab. You can come to our 3D view and check that with the slab strip. So we have designed our slab. So we have our columns passed, our beams passed, and our slab passed successfully. Alright, so that is it. Next thing after the columns, the beams, and the slab, the next thing we are going to design for our structures will be the foundations. And we are going to be using a pad footing for this foundation because the bearing capacity of our soil is at 180 kilonewtons per meter square. So we are going to come to story 0. Alright, a lot of ways you can design pad, but first of all you're going to come to our settings, come to setting center. You're going to click your setting center, come to foundations. Right, this here are going to change things. So allowable stress of our soil, you're going to be using 180 kilonewtons per meter square. Okay, the soil vertical subgrade coefficient is 5000 by the code. Soil unit weight is about 18. Allowable stress, soil stress, ultimate strength factor. This is a factor. We're going to be using a factor of 1.25 from the code. So default pad form, we are going to be using default pad form of square. Let's just use default of square. So the pad base minimum C ratio is 0.2, and okay, that's it. So the next thing I'm going to be, I don't want to use top bars. All right, so I'm going to untick this. I'm going to be using my minimum bar size is going to be 12, and distribution bar size I want to use 12, minimum 12. Okay, if 12 doesn't pass, then it's going to pick 16, but the minimum I want to use this. So pad base concrete cover for foundations. According to Eurocode, the minimum cover for foundations because of soil attack and sulfate attack is usually 50. So it says that concrete cover here will calculated according to the code provisions. So if 0 is entered, in this field, if 0 is entered, like if you impute 0 here, it's going to do it at 50. Minimum is 50. Minimum cover for footing is 50 because of soil attack, chemicals attack in the soil. Okay, so the maximum seal spacing is going to be 250. You can change it to 200 depending on what you want. The link concrete thickness here is 100, more like you're blinding before your pad base. Okay, so once you're done with that, you can just click OK. So once you click OK, you're going to just impute one first. So we'll just click one, right click on it, come to insert pad footings. There's something else we didn't check. So we're going to, once this is done loading, we're going to go check it. Okay, so I'm just going to close this. I'm just going to cancel this for now. Come back to my setting center. Okay, foundations. I want my minimum pad base depth, like the depth. I want the minimum to be 300. And I want my minimum pad footing, like the width. I want it to be 1200. All right, and click OK. You can just click one column, right click on it and insert pad footing. Okay, give it time. So it has provided 1 2 by 1 2 at 300, and also you can come to your rebars to check the rebar provided Y16 at 250, which is okay. Y16 at 250, which is okay. So you can just, everything passes you check here, design is successful and it's green. Once it's green, it's okay. You can click OK and pad will be added. All right, you can highlight everything. Okay, hold your control key and also highlight this. Then you right click and insert pad footing. So you're going to be at, all right, so you just give it a bit time. You're going to be designing this pad footing in batches. Okay, so what you can do is just come here, click redesign all, design all. Okay, and give it time to design all our pad base for our foundations. Okay, so it has done designing it. So this is what it has provided. You can look at it. You can, anyone you're not very okay with, you can just click on it and change certain things that you're not really okay with. Okay, so we can click OK and the pad has been added. The pad, if you notice, because the building was symmetrical, so whatever pad size we have on this side is usually what I have on the other side. Come to a 3D, okay, and you see everything clearly. All right, so we have successfully designed our structures, the columns, the beams, the slabs, and the footings. So congratulations for finishing these tutorials with us. If you haven't subscribed to the channel, please do well to subscribe to our YouTube channel, like this video, and please do well to drop comments. Encourage us by dropping comments. Thank you very much. See you on the next tutorials.